it's an important day, although I know we are these days, it's important that we think about equity and everything beyond male and female, but International Women's Day is still very important. There's also a Homeland Security network that supports women in the enterprise, and our program is proud to say that on this, binary male-female count, we have we are relatively well balanced, and Alison is the metrics keeper. We are relatively well balanced for a Homeland Security program, so we are proud of that, and we're really proud. So we are also proud that we have two great presenters here, and in our lecture series that's organized by Alison. So thanks again, Alison, and sponsored by our advisory council. But today we have the first presentation actual from our faculty. So Eric Best is faculty member, is assistant professor of Homeland Security and Public Policy at the School of Public Affairs here, where we deliver the base program of our online inter-college master of professional studies in Homeland Security. And he is also in the lucky position, like I am, that his significant other, precisely his spouse, Michele, is also his research collaborator, and they do work together, and they're also presenting together. That's great. So thanks for coming. Thanks for taking the time. Let me just briefly take a moment to introduce you. And while I'm doing so, can I let participants know that it will be appropriate to briefly introduce yourselves during the chat. Please don't use Q&A function there, but rather the chat, to just drop 1 or 2 lines about who you are. And then as the presentation will proceed, if you have any questions, you are encouraged to also drop those questions in the chat rather than the Q&A as the presentation develops. And then Michele and Eric may even be able to already address your questions along the way, or then already know what's coming up in the Q&A. And I leave this, how they divide their time, I leave that up to the presenters. So we will conclude at 6. So it will be up to you, Michele and Eric, how you want to divide it up, how much time you want to leave, at the end for Q&A, if you want to, pause in the middle and ask if anybody is. So that's up to you. And but without further ado, I would like to welcome everybody to this evening's lecture, actually on the topic of using canine detection capabilities for odor-based detection or olfactory detection of COVID-19 and other things. So Michele Maughan is a research scientist and program manager specializing in olfactory sciences for the US Department of Defense. In that role, Michele conducts basic research on canine explosive training aids, applied research developing tools to enhance military working dog programs, and performs tests and evaluation for decision analysis. She is also the inventor of the training aid delivery device, TADD, which is a containment and odor delivery system for the precise training of scent detection canines on potentially hazardous substances. Michele attended the University of Delaware, where she, among other things, then ended up with earning a doctorate in microbial pathogenomics. That sounds fascinating. And in her dissertation project, she studies the host immune response to pandemic influenza viruses. So a highly relevant topic these days. And she is joined by Eric. I already briefly introduced Eric. He also already dropped us a note. He only wanted to be briefly introduced. So as you already know, Eric is an assistant professor of Homeland Security and Public Policy, Penn State Harrisburg, our School of Public Affairs. He received his Ph.D. in disaster science and management from the University of Delaware. His research interests include using statistics, GIS, and data science tools to create new applications for hazard reduction, evacuation modeling, and public policy analysis. With that, Michele and Eric, we are so much looking forward to your presentation. Please take it away.
All right, thank you, everyone. Thank you for having us. Thank you for the introduction, Alexander.
You're very welcome, Michele.
Yeah, we're thrilled to be here. I think most of the hour is going to be the exciting stuff that Michele speaks to, and I'm here to both talk about statistical support and then the rare success of an academic professional partnership. So we're an example that it can be done, at least for a while.
All right, so I have an overview slide of some of the work I do in olfactory sciences. And I like to show that slide just because olfactory sciences is not really a hot topic or one that is really well characterized. And so it'll give you an idea of some of the projects and scientific work that goes on behind the scenes in olfaction. So let me pull this up here. All right, so the work I am doing with my wonderful team is called delivering innovative, what we call CBRNE solutions. So that's chemical, biological, radiological, nuclear, and explosive solutions. In that realm, we are using the canine, the dogs, as a detector in some fashion. One of the questions that we are typically asked is, well, how does the dog compare to a handheld instrument or laboratory instrument? And oftentimes we don't have a good answer for that. So we are trying to bring some science to that field so that we can answer those questions and bring some metrology to canine-based detection. In that vein, canines to us are detectors, and they cannot be compared to some of our laboratory instrumentation and handhelds because they are so much more sensitive and specific than our latest technologies. And so time after time, canines have been compared to some of the latest and greatest technologies. However, they are far outpacing them in terms of speed to detection or time to detection and limit of detection in terms of how sensitive their threshold is. So in the course of using dogs and leveraging their abilities and their unique olfactory abilities as military working dogs or in the field of Homeland Security, we have a duty also to protect those dogs. So one of the interesting aspects of when I first started working with military working dogs was that I realized that there weren't really many protective options for dogs. There were a couple of things like the little dog booties that people would put on their dogs, but really there wasn't a whole lot else more robust than that. And so you would see a soldier in their full gear and then really nothing for the dogs. So one of the items that we are developing for canine protection is we have a prototype gas mask that you can see on the top of the screen there. Our main thrust, however, is detection. And that's on the right side of the screen where you can see some of the devices that we are using in our detection portfolio. So there's some stainless steel diffusion tubes there, a breakout diagram of what we call the TAD, the training aid delivery device, and the a graphic for our COVID-19 detection dog study that we are performing with the University of Pennsylvania. There's some other work that we do in terms of evaluating canine wearables, mimicking operations in terms of what dogs and their human handlers can expect in overseas operations, and then also characterizing the tactics, techniques, and procedures that someone would use during a decontamination scenario. So that would be what you would use if a human and a dog were exposed to an unknown substance, that there was a worry that there would be a chemical or biological threat associated with that hazard. And so all of the current decon or decontamination procedures that are out there are really optimized for the human soldier. And there haven't really been any validation of protocols for dogs. And so we're working on changing that, actually. So in that detection realm, we know that we've been relying on dogs for the detection of drugs and explosives for quite a while now. There was military working dogs in World War I. They were heavily relied upon in World War II and every war since then. The use of dogs beyond drugs and explosives is less well known. However, most people would be familiar with perhaps a search and rescue dog. That might be something that would make its way into people's knowledge base outside of drugs and explosives. But there's this entire field of medical detection dogs that have been in more of the research and development phase for quite a while now, even in the realm that we would consider beyond research and development. And so there's been diabetes alert dogs that have been deployed in use for children with type 1 diabetes or adults with type 1 diabetes. There's been seizure alert dogs that, again, have been paired with a human to alert that human before the onset of a seizure so that that person can prepare accordingly. And now there's all sorts of other dogs that we're working with, scent detection dogs that we're working with for the detection of bacterial and viral diseases. There's the London School of Hygiene and Tropical Medicine that recently did some work using canines to detect malaria in some children in, I want to say, Uganda. And that study proved very, very successful. There was also a hospital system in the UK that used a beagle to detect Clostridium difficile in a hospital population. And so that was a bacteria that causes a nosocomial infection in hospitals that is just awful. It's toxigenic, meaning it just causes awful diarrhea in those hospital patients. And so once they're trying to recover from whatever put them in the hospital in the first place, those patients often end up way more sick and often die from these C. difficile infections. So they trained up this one beagle and would walk it by certain wards of the hospital, and the dog would sit by the bed of the infected person. And for a while, they said the dog didn't work because the dog was false alerting on too many patients. So they said they were going to have to scrap the program. And what it was really was that the dog, they said the dog was false alerting because they would take samples from that patient and the samples were PCR negative, meaning they had a negative test by a different, more medically accepted test. And really what was happening was that the dog was alerting to the person's infection before they were PCR positive. And so once they had longitudinal data, meaning they were kept on or repeated testing that individual, that patient, for several days, that patient eventually did test PCR positive. And so it was simply the dog was able to detect the odor of that Clostridium difficile infection or disease state before the typical or traditional medical tests were able to find that. So we're still working really hard to get canine-based detection accepted by the mainstream medical community, accepted by the Homeland Security community. I still work really hard with TSA and various other federal agencies, trying to figure out how to potentially integrate canines into their screening operations as they exist already, because dogs are already in airports and screening for explosives. So it doesn't seem like it would be a far-fetched idea. Is far-fetched a bad dog pun? I feel like it might be. A far-fetched idea that we could also integrate COVID detection dogs like so many other countries have. So I don't know if you all are aware of all of the COVID detection dogs that have been operationalized and deployed in various airports around the world, but they do exist. United Arab Emirates was first, so Dubai Airport had COVID detection dogs. They love being first, and they were the first to get them out there, and then so many countries followed suit thereafter. I forget what the second one was, but since then there's been some COVID dogs in Germany. I want to say that they are in Chile, France, and there's a couple other airports that now have COVID detection dogs out there. So it is possible, and I know there's a private company in the U.S. that is using COVID detection dogs as well, not in the airport, but in stadiums. So they do exist, and that's part of the work that we're doing with University of Pennsylvania, is figuring out how we would potentially move from a research and development type study and proof of concept, although we know the concept works, but we still have to prove it, is moving from that phase into the next phase, which is getting from the sort of the laboratory analysis in these somewhat sterile environments to the deployed scenario, where the dogs are going to be in an airport or a mass screening environment, such as a school or a stadium or what have you. So that's what we're trying to do now with the University of Pennsylvania. And that brings with it a whole host of issues that Dr. Best is trying to assist us with, because what that entails is a ton of statistical analysis and a really tight design of experiment to demonstrate that the dogs are equivalent to or better than our gold standard medical detection technologies that are out there. Those are typical PCR or the rapid antigen tests. However, when the dogs are being compared to those tests also have really, a lot of them have really bad sensitivity and specificity and accuracy results on them. So they're riddled with either, well, I guess it's a lot of false negatives, really. So it's hard to compare a lot of the canine data to what is considered a gold standard, but isn't really very golden, if you will. And so we have to design an experiment that that carefully reflects the sensor, the dog that is being evaluated. And there's a lot to consider in canine experiments that you don't have to consider when you are working with a handheld piece of technology. And maybe, Eric, you want to talk a little bit about some of the things that you take into consideration when you are assisting me to make my experiments a lot better than they start off.
Sure. I'm going to start off by saying I'm hiding out in my basement from my very active children, and there's a very active sump pump. So I'm going to apologize if anybody hears that. I certainly am. One of the things that we try and do, helping the military and the DHS and all of our canine partners, is help them spend their money wisely and create experiments and exercises that can possibly work. And the way that I first got involved in this is I found, data and experiments from Michele and her colleagues where they would say they just had a $4 million exercise, and here's their data, and dogs found their hides 86% of the time. And I would just start asking, normal questions, crazy questions, like what percentage of these runs were blind? And, I would take that data and chop it up and show them that they were actually detecting 20% of the time before they had figured out where the hide was. And then the handlers would go back and tell the other 7 handlers, and then they would detect 99% of the time for a net of 85%. And so what we realized is that we needed to basically have academic quality experimental design from the start before these exercises were ever run, because traditionally what happens is somebody like me will get handed data and somebody will say, this was already done, what can you do with it? And unfortunately, a lot of the time the answer is not much. And so I've started working with our partners to get involved before exercises are occurring, in order to create results that can stand up to, in the medical literature, either superiority studies or non-inferiority studies, which are actually two very different things. So a superiority study is a design that will allow you to test whether a new experimental treatment is better than what exists now. And what Michele was referring to is showing that the canines were no worse. We end up doing a lot of non-inferiority studies showing that the dogs are not having a problem relative to the machines. And Dr. Maughan touched on this, but it becomes a big issue with things like COVID, because you have a time that you're infected and infectious, and then you have a time where you will hit positive on a PCR machine, and those two things are not necessarily the same. And so a lot of what we're having to do with COVID and similar instances is we're having to track data afterwards. So track longitudinal data, test everybody that a dog walks by again 48 hours later to confirm whether or not we had a false positive. And this, for those, I see there's a couple students that are in my PADM 504 statistics class that are on the panel tonight. That's wonderful. This is actually the exact same stuff that we do in there. We create a very complicated null and research hypothesis, and we make sure that we set studies up where they'll be statistically valid. We have our power calculations, which are super important for the dog work, because we have a lot of small n samples for things like this. And basically I just spend most of my time fielding questions about why do we have to do this more complicated thing. And just like that class, the answer is almost always because your analysis is going to fall apart if you don't. And so I have a lot of I do a lot of disappointing in the canine world. Somebody will come very proudly and say this works, and then hand it to me, and I'll have to look at it and hand it back and say, maybe if we do the following things next time, it actually will work. But that's something that's getting a lot better with this COVID work. And thankfully the projects that are happening this year are run from the ground up in a way that we'll actually be quite confident about the results. And so that's hopefully leading to a change in the canine programs, but we will see. So, anyway, there's lots of validation, lots of thought that goes into this. It's actually more similar to a medical trial than it is to what canine used to be, which was just, summary results of data talking about detection. And I'm glossing over quite a bit of things, but it's also tough to tell when a dog detects. We've started using some GPS collars to actually track the paths of dogs in outdoor exercises to figure out where they're spending their time. And one of the things that we're finding that might change how we have to think about the dogs is that sometimes they're hanging out in an area before they're officially detecting. And so, a lot of times the dogs might be trying to tell us something that we're not necessarily picking up on. And so we're using a lot of new tooling to try and figure out if we can get answers about those questions. So it's a lot of a little bit of traditional stat, a lot of Bayesian analysis, which I'm a big fan of, a lot of spatial analysis, which I wasn't necessarily prepared for, but it's allowing us to do some very cool things. And then, as I say in PADM 504, there's also the most important part, which is efficiently and correctly communicating these results so that people like Dr. Maughan can actually do what they need to do to make more effective exercises in production. And it's worth noting that this is all applied research. The end goal of all of this is that dogs are out working. And so there's, a high standard that we have to live up to. There's a lot of money that's spent on this. There's a lot of dependence on these animals and their handlers. And so we have to make sure that we're confident in what we're doing.
Yeah, so Eric brings up a really good point. We are integrating a lot more technology into the canine work that we're doing. Everything from those GPS collars with a lot of really high resolution of where the dogs are in their open area searches. So if they're in a large field, or if they're going on a long distance area search, for, like similar to search and rescue, or the avalanche dogs, or what have you, that those collars are really helpful in terms of capturing all sorts of little movements that the dogs are using and engaging in while they are working to source, which is the highest concentration of odor. So the dogs are following their noses to their trained odor, and they do that using all sorts of different tools that are inherent to their body, but they have the slits in their nares, and based on the concentration gradient, they can tell whether they should be going left or right. So if the odor is stronger on the left side of that slit, then they start going left. If it's stronger on the right side of that slit, then they start going right. And so they're constantly surveying the air around them and trying to figure out where to go next. And there's so many micro movements that we're still not capturing that we should be, because there's a lot of data lost in that. But we are getting sort of the bigger picture now with the data from those collars. And so we can see where the dogs are starting to go in the bigger picture, as opposed to just saying the dog went from point A to point B and it got there in an hour. We can say the dog got from point A to B, took an hour, but it took this crazy circuitous route to get there. And it's probably because odor was pooling over here, or it caught some vegetation over here, or there was wind patterns, or all sorts of different things that can happen along the way. So the collars are certainly helping. I know that we are planning on integrating the follow me technologies on drones as well, so that we can have a greater perspective on the sort of the overhead picture of open area searches. There's a lot of data that we're missing when we look at sniffing behavior. So we know from some controlled studies that dog sniffing behavior is different depending on if they're sniffing a novel odor, or a familiar odor, or a trained odor that they've been trained to recognize, like an explosive detection dog is sniffing its trained odor of C4 or TNT. And so the sniffing pattern changes and it's distinct. So there's a lot of information that we could be capturing if we were listening, or if we had some sort of wearable on the dog that had the ability to capture some of that sniffing behavior. So that's some of the other piece of the picture that we would love to be capturing, but we're not. So hopefully we can start integrating some of that information into our studies. One of the interesting things, like I touched on earlier, about how canine studies are different than some of the handheld or laboratory instruments, is that when you're doing a canine study, you're testing a sensor that is learning. And so that is what is different than all of the other technologies, meaning when if you expose a dog to an odor, and you pay that dog, meaning you reinforce that odor with a reward, like a toy or a piece of food or whatever that is. So you pair those two things, the food or toy and that odor, you start conditioning that response. And when you condition the response, you are creating a link for the dog. And so that link then becomes a learned behavior. And so that next then experience for the dog of that odor is learned. And that is important when you're looking at a data set, right? Because that first exposure to the odor is different than the second exposure to the odor. And that's the type of stuff that Eric needs to capture in his statistical analysis, because they need to be weighted differently to account for the first and second or subsequent exposures to that odor, because they're not the same once the dog now knows that odor. And maybe Eric has a better way of describing that in statistical terms. I'm sure he does.
Well, so there, now that we have learning non-dog sensors too, it's actually getting more complicated. But we have a couple of great questions that it's actually worth weaving into the conversation now. So I'm going to go on a random walk that I think is going to answer those and speak to what Michele is talking about. One of the things in chat was a question about sensor fusion. I assume that's asking, are we doing it? And the answer is all the time. What the kind of work that the DHS and especially the military is doing with dogs is very front loaded. That we're trying to give them very good data about what's happening so that when they go out in the field they can answer questions in seconds. Because some of this is obviously extremely high stakes, right? Like if you have a drug detection dog sniff something and they miss a cargo container, at the end of the day, who cares? But if you have a person-born explosives dog that hits on somebody, that's very likely a lethal consequence that is going to happen in seconds. And so, we have to be ludicrously confident in this process and this data. And so we're, everybody that's involved in that is basically using every sensor they can in a very complicated, very quick fusion dance. But it's also worth noting, and this touches on another question about the cost benefit of technology versus canines. That's an ongoing battle that's changing constantly, right? Digital sensors are getting massively better at a lot of things all the time. Right now, I'd say that the dogs still have a big advantage, but there's going to be a day where that switches, and then Michele's going to be doing something else, and we'll find out what that is. But right now, it turns out that when we're doing this work, we don't only have to test the dogs, we also have to test the sensors, because it turns out there's a lot of digital sensors that don't actually do what they're advertised as doing. And I'll point out that does not necessarily mean they are ineffective. But this gets back to stat class again. If you get the right answer the wrong way, that's actually a very different conversation about what's going on than if you get the right answer with a correct process. And so are the largely government entities that are doing this work analyzing the cost benefits all the time? Right now, and I would say for the foreseeable future, I think canine will pay off. And I think this, Michele, you're the one that should speak to this, but there's entire branches, disparate branches of detection canines. And you might want to talk about how dogs are and specifically are not cross-trained, which might be interesting to this group.
Yes, dogs are kept in a discipline based on the threat that they are detecting. And The military specifically tries to get the biggest bang for their buck in terms of using canines not only for a detection purpose, but also for a force protection purpose as well. Meaning those dogs are considered dual purpose, in that they can catch bad guys and serve that bite and protect function, and also find explosives or drugs. So in the military's way of doing that cost benefit analysis, they actually are getting a lot out of those dogs. The dogs in the Homeland Security program within DHS or TSA are single purpose dogs. Those dogs are only sniffing for explosives. And so the analysis would be very different for those dogs. They do not require a protective function for fighting the bad guy. Those dogs need to be able to function well in and amongst the traveling public. And so it's a very different type of operation when you consider the types of dogs that you're using for what the end goal is. A lot of times people will ask me, like, are there certain breeds that you have to use for this purpose? And, or can, you know, one dog smell this threat better than another one? And the answer for the most part is that almost all dogs can do detection type work. And actually a lot of different types of animals can do it. Elephants have a much better olfactory ability than dogs do. It's just the tactical application of elephants is not there. And so, you know, that's not something that that's something that we have to consider is how that downstream application is going to work. So there's been some use of dachshunds as a detection dog. So those are like the little wiener dogs that are long and narrow and tiny. And you would think, what in the world is that type of dog going to be useful for? Well, they use them in submarines and ships for the Navy for drug detection. And those dogs can go in the rafters and in the ventilation systems and all over the ship, and they fit in everything. And so that dog works for that purpose. And the German Shepherd, the Belgian Malinois, and the Labrador Retriever work really well in the Homeland Security and military application based on their ability for, you know, sporting that type of breed that has the tenacity to work long shifts, has the drive to please its owner, to they call it prey drive, to go forward and get that ball or get that reward. And those breeds are very muscular and sturdy, so they make great military working dogs or TSA dogs. And then when you think about like a service animal, you want a dog that's really, really calm and quiet and sort of like always in a sort of meditative state, right? You want a dog that's not reactive to anything. And so that's kind of the opposite of a working dog. And many of the dogs that actually wash out of a working dog program for not having enough motivation become service animals for people with disabilities. So they're still super smart. They just don't have the same type of drive that you would want in a detection dog. So we tend to find really good areas for dogs to work depending on their breed and personality. And there's almost a job for any one of them. But they can all detect really, really well. And actually there's a sport called nose work, where it's a hobby sport that people do with their dogs. So you've probably seen people do agility work with their dogs, where they're sort of, throwing Frisbees, and then dogs are sort of weaving in and out of these poles and having fun like that. Nose work is where people will take their dogs, it's a hobby sport, and have their dogs find essential oils all over the country, people will travel and do the sport. And I've seen dogs that I didn't think could, smell their breakfast, let alone could go and find an essential oil out in the middle of nowhere, but the dogs do it. And I've seen, little Chihuahuas do it, and I've seen, rickety old arthritic Huskies do that sport and rock it. So there really is a great depth of detection abilities, regardless of the breed of dog. We do tend to put certain dogs into dog breeds into certain disciplines, only because we know that the dog's going to be very good at that. And so there's not a whole lot of reason to change things up if we know that the dog's really good at that. So for bloodhounds, we'll use bloodhounds for a lot of tracking and trailing. Bloodhounds have a great sense of smell, are low to the ground, and their big floppy ears are actually really good for getting into the ground and wafting up the disturbance in the soil or the grass or whatever surface they're on, and picking up human scent, and then that helps them track the disturbance or the trail of the person that they're tracking. So that's just a genetic or breed feature that makes them extra good at what they're doing. But a German Shepherd with pointy ears can also do tracking and trailing.
Should we talk specifically about the process of training up the COVID dogs, how you did it, and then also how it works?
Yep. So the COVID detection dogs, they're trained internationally. Everyone took a sort of different approach. The approach we took at the Army and University of Pennsylvania was initially to start the dogs on clinical samples from asymptomatic and symptomatic patients that were COVID positive. And we had obviously COVID negative people as well, so that the dogs would discriminate between the two types of samples from patients. We used saliva and urine, and simply by presenting repeatedly and doing that reinforcement of the sample that you want the dog to smell, so the positive sample with the reward, food or a toy, and continuing that positive reinforcement schedule over and over and over again, we were able to train the dogs to alert to the COVID positive samples. I think it was 3 months or so. And then the next stage of the study, which is what we're doing now, is training the dogs on the odor of COVID based on human scent. And really that's the sweat or metabolites that you're producing in response to infection. And so patients are able to participate, they volunteer, they wear a t-shirt overnight that they then send back to the University of Pennsylvania. And that t-shirt is then cut up into little swatches, and then the dogs are training on those swatches as their training samples. And so that is the sample set that we're using now for training the dogs, which will hopefully correlate more closely or distinctly towards a human screening capability, because dogs will clearly be recognizing that smell on your clothing as you walk through an airport, or in your baggage as you walk through an airport. So that is the next stage towards an operational capability. And then we'll see if we get interest or funding for additional stages thereafter. For the most part, there hasn't been a lot of interest on the DoD or DHS side of the house for a COVID detection screening capability that's canine based.
There is private interest, though.
Yeah,
talk about that. There's massive demand from industry to get dogs that will get people back in seats, and that's actually going to be interesting to watch as spectators, because I do wonder if a lot of those programs are necessarily working. but they're gonna be out there.
Yeah, so there's a street price of anything from $80,000 to $100,000 a dog that's being offered for a COVID detection dog. That for the casinos out in Vegas are desperate to reopen to full capacity. Cruise lines want to get sailing again. Stadiums want to open. Schools want to be at full capacity. So there's lots of interested from at least the private industry that really wants to get going again. Entertainment's hurting really badly, but also warehouses have an issue staying open as well, just because, again, close quarters and just a large population. Whenever a large population has to work together, that's the risk envelope increases. We also were contacted by a group that wants COVID detection dogs for like having a large military exercise. They have a lot of those throughout the year, throughout the summer especially, and they'll have 5,000 people descend upon a certain location or certain military base, and they'll try and keep that 5,000 people from having a COVID outbreak. It's not going to happen without an enormous cost of testing or screening. So there's certainly requests for it, but no one really wants to foot the bill. So we'll see if it takes off or not.
Michele, there's a good question about whether or not you do selective breeding to try and improve dogs across generation.
So the Europeans have, and that's why the US gets all of their working dogs from Europe still. So the US really bred most of their dogs for phenotype, for the look of the dog, and didn't really have a culture of working dogs. Whereas in Europe, they had a really strong, or at least Western Europe for the most part, had a really strong, actually not just Western Europe, Europe has a really strong culture of working dogs, based in a lot of sport dog stuff like Schutzhund and IPO, but they bred dogs for more than just phenotype, but also for genotype, like that workability, and a lot of the ways they define that. But that's also by how drivey the dog is for prey drive, and other genetic factors that would lead to really good, healthy, solid working dogs. So Europe did a really good job of that. The US not so much, and that's basically why we are where we are in terms of having not enough detection dogs. That's a crisis that's well known in the US or the working dog world, and why we have to source our dogs from overseas. Is there a methodology to improve the next generation? I have one. I've pitched it a couple times and people think I'm crazy, but I've been talking about cloning. They think it's Star Warsy, and it's totally not. Cloning happens all the time, and it's totally accessible. It's not a big deal. It's basically just a faster way to get from point A to B that you would do with selective breeding. And it's probably the only way we'll catch up to what Europe's been doing for generations. So I think we'll have to go to cloning and start up a program if we want a domestic steady supply of working dogs.
Okay, wonderful. That's been intriguing. Are there any other questions out there as we are 8 minutes out? Or are you I thought that was like you were ready to take questions now, right? Or is that?
Yeah, sure.
Great.
I can put everybody over on the open their mic, since we're down to 4 people were able to stay, if that will help.
So you could write or raise your hand, and then Alison can give you mic rights, and then you can also verbalize your question. JJ. Yeah.
Hey, how you doing? My name's Warren Kaufman. I'm a first semester HLS. I'm doing the counterterrorism option. I asked the sensor fusion question. Thanks. You kind of answered it before Eric was able to get to it. So good to hear you guys are doing that. That makes the most sense to me. But my next question is, you talked about elephants, and there's better animals equipped out there. Not equipped, but animals that in certain aspects would be better equipped to sense these seaburn events, or or what you'll call them. I mean, have you looked the other way? Does this cross over into, the old, having the canary in the mine, in the coal mine things, sense the levels of oxygen and stuff? Are there different animal tests going on in addition to canines? Because I understand an elephant doesn't act like a canine, isn't as transportable. The relationship isn't there. But are you using this to further other research for other mammals that can be maybe located in airports, large events that are not as military or police law enforcement looking as a military working dog or a canine?
Would it would the animal be disposable potentially?
Well, I mean, you kind of touched on it at first. You talked about rewarding the dogs with finding the scent. I kind of put two and two together that if a dog finds the scent of a radiobiological, nuclear, or something, that dog probably is considered dispensable at that point, because it's there's going to be instant feedback. And I mean, we're talking extreme case here.
Right.
So I think that's relative. I'd say dispensable is relative in this case.
Yeah, absolutely. So yeah, we try to stay away from the hairy canaries. So we don't want the dogs to be disposable at all. But yeah, we realize that there's, different cost of life when it's, human versus animal. There is the what they call pouchies, giant African pouch rat. And that is an animal that has also a wonderful sense of smell. It's about the size of a small house cat, and is used in prison systems in Africa. And we're doing research on them on the U.S. side of the house for sniffing out tuberculosis. And so those animals can put an end to infection that would normally just, sweep through a prison and get everyone really ill. Those animals can find the infection really quickly, find the infected patient. They can get removed from the general population and provided medical treatment really quickly. So there are what we call lower order animal species that we're doing olfaction research with. Even people will work with there's different types of insects that have really good sense of smell as well. And so they'll use the hoarding effect of insects to figure out if the insects have a preference for certain odors. And they even use that for some of the preliminary work in malaria. And so they would have the mosquitoes cordoned off from the humans, and then they would see if the mosquitoes would sort of all group together in one side of a tube or another side of a tube. So there is a little bit of that. I wouldn't say that there's a large investment, because in general, there's not a large investment in olfactory sciences at all globally. We've done a ton of investment in exploiting the auditory realm with sonar, and the visual realm with LiDAR, but we just really haven't focused much on olfaction. So there's a ton of tech out there that just hasn't been even explored.
Okay, I understand. And yeah, I'm from a military background. That's why I focused on kind of the military threat, the seaburn threat. But I think it's incredible the healthcare stuff that's going on too. That's pretty impressive.
Yeah.
I'm glad it's going on, because obviously my first thought is military working dog, go get the bad guy type thing. But it's keeping the homeland safe. There you go.
Right, and that's what's sort of incredible is the range of things that they can do. It's like biting is almost a waste of all the applications that they can do.
And there's also some very different purposes. Like one of the things that I just get a lot of joy out of now is every time I'm at the Denver airport, where a lot of times there were announcements that these dogs are only sniffing for explosives because Colorado had legalized marijuana, and you just see a TSA dog walk by and you see some 22-year-old do a 180 and walk as fast as possible away as they can from the dog, to the point where they actually had to announce that that's not why the dogs are here.
Well, and that's I was going to say, it was going to bring up about, keeping the dog's survivability up, because I mean, obviously during the heavy days of the drug war, I mean, there was counters to dogs that that people were learning. We were losing dogs over that. So, cool. Okay. Thanks for the.
Yeah, and those counters are still there for everything. They're there.
That's what I'm saying. They'll
explosives.
just adapt. And,
Yeah. So that was what was interesting as well, was, I was contacted by Customs Border Protection because while there's the whole war on drugs and everything, and the opioid crisis, and fentanyl's been spiked into heroin and all this other stuff, the Customs Border Protection has a very different mission, where they're finding 55-gallon drums of, fentanyl or carfentanil from China, right? Like, they're not dealing with little bits of spike stuff. They're dealing with, it coming in en masse. And so when their detection dogs are coming or being confronted with that, they have to still train to detect it, but how do they train on that safely? And so that's when the device I invented comes into play, where it's the training and delivery device, where the dogs can smell the odor of the material but not be exposed to it, meaning all that comes out of this, all that comes out of this thing is the odor, not the actual substance. So this could be fentanyl, this could be anthrax, it could be anything. And all that the dogs can get access to is the odor, not the actual particulate. So these are the type of things now that enable dogs to train on hazardous material without becoming intoxicated, infected, whatever it is.
Interesting. It's 6 o'clock now, but we have one open question from Mark in the chat. Michele and Eric, would you like to still address that before we conclude?
Oh, we can address that. There's a vaporwake dog in this house that just drives me nuts, but I'll let Michele talk about it.
All right. In terms of operating COVID-19 dogs, is the end goal to use them as vaporwake dogs, such as a stadium or other large venue, or point of source, subject specific, or both? Yeah, both. So it depends on the ConOps, the concept of operations depends on the end use and who the end user is and who's essentially buying or sponsoring the research. So the private industry folks are typically using them in a more vaporwake scenario, where they are doing screening en masse. They're still lining people up though, and creating a lineup, static lineup, so that the dogs have an opportunity to search each person. So they're not really using it like full vaporwake style. There's hospital systems that are trying to train COVID dogs as well. They're trying to use it more like you bring the patient sample to the dog. And so that would be more subject specific. I think if that's how I'm understanding the question properly.
Wonderful, great. With that, I would like, since we are online, I'd like to take this opportunity to present you your certificates of appreciation for presenting tonight this way, but I'll also send them your way through the email. That's been fascinating. That's wonderful. So thank you, Michele and Eric for presenting. And we're also looking forward, as we're recording these things, to use clips of it in our classes to enrich our online courses. Thanks for joining. I also would encourage you to join us again next week, when another member from our Homeland Security Advisory Council, Bert Tassing of the U.S. Army War College, is presenting on Homeland Defense and defense support of civil authorities, DESCA and such. Same place, same time. Be safe, have a great rest of your Monday, and have a great rest of your week. Bye-bye. Thanks again.
Thank you, Alison. Thank you, Alexander.
Thank you.
Thanks for having us.
Recording is